Hello guys, welcome back to this channel. Uh, in this particular video today, we are going to be learning on how to solve set operations. I'm going to be solving some examples so that you can see how set operations are being solved. So in our last lesson, we discussed about set theory. We talked about the definition and set representation, how set is being represented. And in this lesson today, we are going to be talking about our set operations, and we are taking examples on how to solve set problems. So I want you to stay with me till the end of the video so that you get maximum value from this particular video. And I want you to click on the red button, the subscribe button, and turn on the notification bell so that whenever I drop a tutorial video relating to topics in mathematics, you'll be the first person to get notified. Help me share this video with your friends and loved ones. So let's go into the lesson of today. So we're going to take two properties of the set, and from after this we move directly to set operations. We have one important property called the cardinality of the set. The cardinality of a set. Now, if you look at the set A has 5 members: 2, 4, 6, 2, 4, 6, 8, 10. So we write 8 as the numbers of elements of A is equal to 5. The cardinals of A is 5 because A has 5 elements. So the cardinality is 5. Also B, we have the element 1, 3, 5. So the numbers of the elements of B is equal to 3. So the cardinality of B is 3. And also C has 8 members. So the cardinality of C is equal to 8. So cardinal of a set is the numbers of members or elements of the set. Numbers of members or elements comprising in the set. That's the cardinality of the set. Now power set or power of the set. Power set. Now consider this particular set A having 3 members, 3 elements, 1, 2, 5, and the powers of the set is telling you how many subsets can be produced from that set or can be extracted from that set. So if you are taking the element one by one and you begin to write subset, you discover that this set can be a subset of the set. 2, 5, a set of only one member can be a subset. 1 and 2 can be a subset. 1 and 5 can be a subset. 2 and 5, and 1, 2, 3, 5, as well as this empty set. So if you count the number of subsets we have produced from this set, we have 1, 2, 3, 4, 5, 6, 7, 8. So this set with 3 members can produce 8 subsets. So there's a formula we use to calculate the subset, number of subsets produced by a set, which is P equals to, P means power set equals to 2 raised to power n, where n is the numbers of the elements. Now in this case, the element here of this set is 3. So n equals to 3. So if you apply the formula 2 raised to power 3, we discover that this set can produce 8 subsets. I hope you understand that. Alright, so you are welcome back. I believe from the lesson so far, you have been able to get some ideas on set theory. So in this particular lesson, we are going to be looking at set operations. So if you have not subscribed to the channel yet, I want to urge you to do that and click on the like button and also comment in the comment section. I understand set theory. So now we want to take two set operations, which are the set intersection and the set union. Two set operations that is very important in set theory: set intersection and the set union. Now if you look at this particular A part, is saying we are supposed to examine R intersection Q. This symbol that stands like N, elongated N, it means intersection. And the second one says we should find R union Q. This one stands union. So the set R is the set of all positive integers less than 20. So you know that the element of the set R will be equals to, since it is all positive integers less than 20, we have it to be 1, 2, 3, 4 to 19. That's it, to 19. Positive integers that are less than 20, 1, 2, 3, 4 down to 19. So numbers in between 5 to 18 are part of it. We've represented with the dot dot. We see that this set is a terminating set. So we have set Q, all factors of 20. All factors of 20. That is 1, 2, 4, 5, 10, and 20. So these are the factors of 20 here. So now we are expected to examine R intersection Q. R intersection Q. The intersection of a set, is actually the elements which belongs to both of this set. Can you see now? In this element now we can evidently see one is an element of Q and one is an element of R. So one is actually we are listing out the element without repetition. So 2 is also an element, 2. So 2 is part of it. We also see 4 here. 4 is also part of it. If we have continued this list, we see 5 is part of it. 5. We continue it, we see 10 is part of it. And that's the last range. That's the last number, that is the element of set. So R intersection Q is the elements are 1, 2, 5. We cannot repeat the 5 twice. So 5 is only, the elements can only be written once. So 1, 2, 5, and 10. These are elements, these are the members elements of R intersection Q. So if you want to write R union Q, the element of R union Q. R union Q is actually the combination of the elements that belongs to R and Q without any repetition. So we are going to write, since R is from 1 to 20 and Q is also 1, 2, 4, 5, and 20. So we are going to write 1, 2, 3, 4 to 20. So this is the element of R union Q. The combination of these two elements without any words, any repetition. That's his meaning of the union. Obviously, I believe with this example, with this illustration or the explanation now, you've been able to understand the concept of intersection and union of the set. So we will take some example in the next part. We take some examples on problems that involve operations of set. So take it home. So in this particular example, we are given the universal set, and the universal set here is elements. The elements are 6 members: 1, 3, 5, 7, 9, and 11. And we are given set A, which is a subset of the universal set 1, 3, 7, 11. Also given set B, 3, 5, 7, 9. And we are given set C, which is 3, 7, 11. We are asked to find, the first one is A intersection B complement. And second, we have to find A complement intersection B complement. Third one, we have to find A complement union B complement. And the fourth one, we have to find A union B or complement. So how do we go about this? We are already, first thing we are supposed to find is the set of A intersection B complement. So we know the set of A. This is the set of A, but we don't know B complement. So we have to write B complement first. So B complement, I forgot. Recall that B complement are elements that are in the universal set, but not in B. So we have 3, 4, 7, 9 in B. So in B complement we have 1, and 11. 1 and 11 in B complement. 1 and 11 in B complement. So 1 and 11. So in B complement, yes, 1 and 11. So we are now comparing it with A. Set A is a set of 1, 3, 7, 1, 3, 7, and 11. 1, 3, 7, and 11. So we are now looking at what the set to be, what is common to A and B complement. So we can now write it as, I think 1 and 11. 1 and 11 is the answer to this A intersection B complement. That's the element that is common to both of them. That is for number I. Now for I, we have to find A complement intersection B complement. We have to find A complement intersection B complement. And we know that A complement already. We don't know A complement. So A complement, this is A, set A, 1, 3, 7, and 11. And this is the universal set 1, 3, 5, 7, 9, and 11. So which elements are not in this thing? 1, 3. So we can see that 5 is not. 5 is not there. 9 is not there. And so I think those are the two elements that are not there. That's 5 and 9. That is A complement. And we have B complement, that we have already gotten B complement here. B complement is set of 1 and 11. So if you look at these two sets, you discover that there is no element, that is the what. So we can have the answer to be written as a null set. So we can have it to be written as a null set because there are no members that belong to A complement and B complement. So I hope you are getting it now. So 3, we have we have A complement union B complement. A complement union B complement. That is what we are expected to find in number 3. So this is A complement 5 and 9, and this is B complement 1 and so union. We write the union set, the combination of the element of A complement and B complement without any repetition. So we have 1, 5, and 9 and 11. So it's always important that whenever you're writing it, if it's a number, you write it in ascending order or you write it in descending order. But be organized, writing your element, and every of your element will be separated with a comma. Without the comma, it's just going to be an element. So, but if you separate with a comma, it makes it to be different elements in the set. I hope you understand what I'm saying. So the last one that we are doing here is 5, which is A union B complement. A union B complement. So A union B, we don't know what A union B is first before we think about the complement. So let us first write A union B, the set of A union B. Set of A union B. This is A here, and this is B. So we are going to write the elements. We can discover that 1, 3, 5, 7, 9, and 11. This is A union B. A union B. 1, 3, 5, 7, and 11. That's A union B. Then we are now going to write A union B complement. Since we have 1, 3, 5, 7, and 11, let's look at this is 6 members. The same thing. The complement. The complement is also a null set. No element. Every element in A union B is an universal set. So the complement is also a null set. So these are practical examples of set operations that you can have if given to you. You can also go for further consultation with your textbooks and look at. I'm still going to. So thank you for learning to the end. We have come to the end of this tutorial on set operations, and in next video we are going to be solving problems relating with Venn diagram. And there was a mistake in one of the set operations where I wrote repeated 5. The first 5 is supposed to be 4, so please make that correction. That first 5 in the first example of set operation is supposed to be 4, so make the correction. So thank you for watching. Please share and subscribe to the channel so that when next I drop in another video, you'll be the first person to get notified. Thank you.